In this section, we're going to talk about drawing motion maps. A motion map is a new type of diagram that combines some of the aspects of a velocity time graph and a position time graph to kind of represent the motion. I want you to recall that when we did the lab, you were chasing the little cars down the hallway and placing pieces of tape on the floor at the location of the car as it continued down the hallway. And so as the car moved down the hallway, I'll draw a little car here, right? You were placing little pieces of tape on the floor every 2 or 3 seconds or whatever it was to represent the location of the car. A motion map is kind of similar to this idea. So here's a position time graph. This is the kind of position time graph that we got from the lab. The motion of the car was forwards, to the right, in the positive direction. It was a constant speed, so the line has a constant slope. It doesn't bend or turn or anything like that. Some of you use that idea when you were measuring the tapes because you noticed that some of the tapes weren't necessarily equally spaced, and you decided to go back and make new measurements because you felt like they should have been evenly spaced, and you were correct. So to draw a motion map, I just start by first of all drawing a number line here representing like the tape measure or the hallway. Next to the number line, I'm going to draw a series of dots representing the location of the object or the car, in this example the car. So the dots represent the position of the car, and then on the dots I'm going to draw a little arrow to represent velocity that shows the direction the car is moving and shows how fast the car is moving. So the arrows, if the arrows are long, then the car is moving fast, and the dots would be spaced farther apart. If the arrows are short, then the car is moving slowly, and the dots would be placed closer together. You should never draw anything where you have a bunch of dots and then the arrows overlap the dots and look messy. Okay, always try to keep the spacing kind of even. If it's moving slowly, you're going to draw the dots kind of close together. If it's moving quickly, you're going to try to draw the dots farther apart. Okay? So you should never have any situation where the arrows kind of overlap and make a messy looking sort of diagram. We're trying to communicate information clearly, so a neat diagram is good. Here I have another example showing an object that goes forward for a while slowly and then goes fast for a little while. I circled this point there to kind of represent where the speed changes. The velocity graph that would match that would have 2 horizontal lines, both of them above the axis in the positive zone. Positive, slow, positive, fast, slow, fast, lower, higher. This circled area right here represents or is shown on this graph by this dotted line where the speed jumps or changes. And the motion map would have, I like to draw for a segment of line 3 or 4 dots. Okay, so each segment, not really trying to match up time and distance perfectly here. I'm not, right, the idea is I'm trying to draw the right idea, trying to get the right accuracy without all the numbers, without getting too bogged down and making all the numbers match exactly. So the first 3 or 4 dots here represent the first section of the line, and then the next 3 or 4 dots represent the other section of the line, without trying to do a one-to-one sort of match it up perfectly. This section is moving slowly, so the dots are spaced kind of close together with small arrows, indicating it's moving slowly. This section, the object is moving faster, so the dots got farther apart, and the arrows got longer as a result. The circled point here, again, represents the moment when the speed of the car changed. If we had something like this, where the car changed direction perhaps, I see from this graph that the car was moving backwards at kind of a quick speed, then stopped moving and stood still in one place for a little while, and then when it moved again, it moved in the positive direction to the right, but at a slower speed. My velocity graph would look something like a set of stair steps, and the motion map, I would start at some location. It's nice to label the start point as 0 seconds, and it would move to the left at kind of a high speed for a bit, with bigger arrows and farther spacing. Then I see that it stops, okay, so it goes, right, we just draw a couple of dots up or down, it doesn't matter, and then it moves slower, so closer together dots with smaller arrows indicating that it's moving slower and to the right.